Okay, we're down to the wire. We are on our last part of vectors in component form. You can remember from when we did scalar multiplication from an earlier video that when we did it geometrically, let's see, let me pull out a pencil again. If we have vector A, then if we have 2 times A, then we have a vector the same direction but twice as long. So this would be 2A right here. And a scalar, remember, is a non-vector quantity. So a scalar would be something like, I don't know, 2, 4, 1/2. It doesn't have a direction or a force. It's just a scalar. We also use the word scalar to mean constant number. So for example, if we have A and we have vector A here, it's 1, 3, and then A plus A, because we learned how to add those vector components, would be 1 plus 1, which was 2, and 3 plus 3, which is 6. We have the vector 2, 6. And then A plus, oh, that back here would be 2A. Right? If I add A together, A plus A is 2A. And then A plus A plus A, that's 3A. And if I add them components up, 1 plus 1 plus 1 is 3, and 3 plus 3 plus 3 is 9. And so that's my resultant vector. So what we can derive from that is that if K is a scalar, then right here, 2 would be K, and 3 would be K in this instance. Then K times A is just simply K times each component of the vector, right? If I have 2A here, 2 times 1 is 2, and 2 times 3 is 6. And if I have 3A here, 3 times 1 is 3, and 3 times 3 is 9. All right, let's try an example. I have 2 vectors here, vector P and Q. The first thing I want to find is 3P. So I'm going to just take my components and multiply both of them, the x component and the y component, by 3. And I end up with a vector 3, 15. Okay, let's try something a little bit harder, but not too hard. Let's find 1/2 Q plus P. All right, so I'm going to take the Q vector and I'm going to multiply each component by 1/2. And to that I'm going to add P, the original P vector, where the x component is 1 and the y component is 5. And when I do that, 1/2 times -2 ends up being -1, plus 1 gives me 0 for the x component, and 1/2 times 4 is 2, plus 5 is 7. So my resultant vector is 0, 7. Here's a few for you to try. Pause the video, work through the problems, and then come back and check your answers. Okay, hopefully you got the right answers. 3Q is vector 6, -9. Well, let me get my little laser out. P plus 2Q ends up being 8, -5. And then 1/2 P minus 3Q ends up being -4, 9.5. Ooh, I don't like that. I like 19/2 better, but whatever. All right, the other thing we need to talk about is the length of a vector. You'll see here that I have a vector, vector A, and it has the x component of 2, and the y step is 3, and I have it drawn here for you. Okay, if I want to find the length of this vector, I can simply use Pythagorean's theorem. Right? I have a side length of 2, a side length of 3, So I can use a squared plus b squared equals c squared. And let's set that up. 2 squared plus 3 squared equals a squared. 2 squared is 4, 3 squared is 9, so that's 13 is equal to a squared. So a is radical 13, which means that a is roughly 3.61. We call that the magnitude. So this length is about 3.61. That's the magnitude, and that is always a positive number. It's as easy as that. And don't forget from an earlier video that we wrote the magnitude of a as it looks like the absolute value function. All right, there, I'm trying to keep it short, but there's one last thing I needed to talk about, and that was vector equations. So the rules for solving vector equations are almost the same as solving regular equations, except the only difference is if I have vector A, I can't divide vector A by a number. That doesn't exist. We get around that, though, by multiplying by the scalar 1 over 7 times vector A. So that's how you get around it. Solving vector equations is almost the same. There's 2 rules that are useful. Rule number 1, if x plus a equals b, well, just like a regular equation, x equals b minus a, or b plus negative a. Rule number 2, if kx equals a, well then x is equal to 1 over k times a. So my last example is if I have 3x minus r equals s, x, r, and s are vectors, and I want to solve for x, then the first thing I would do, just like any other equation, is add r to both sides. And then to get x by itself, I would multiply both sides by 1/3 to solve for vector x. And that's it. Thanks for sitting through all 3 of these videos.